Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's episode 9 of Learn How to Sudoku. And today we're going to be learning on this very easy puzzle called Trash Panda by New Beidel. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Killer cages. Digits in a cage may not repeat and sum to the total in the top left corner. So for example, these three digits must add up to 13. So a valid example of this would be 3, 4, and 6. And that's how cages work. And you cannot have repeats, but it's not that important because you can't have repeats in normal Sudoku rules too. So that eliminates most things, most duplicates anyways. Crop key dots. Cells separated by a black dot have a ratio of 1 to 2. So for example, if this were 2, this would have to be 1 or 4 to maintain the 1 to 2 ratio. German whisper. Adjacent digits on a green line have a difference of at least 5. So basically, an example of this would be if this were a 3, this would have to be an 8 or a 9 to basically have a difference of 5 between them, right? Extra regions. Now, this is a kind of new rule set. Gray cells form extra regions containing the digits of 1 to 9 once each. So you can think of those as basically just another, something similar to a 3x3 box, right? Except that it's just basically the region is this region instead of the 3x3 box. And it's the same for this one. This one is also, you have the digits 1 through 9 once each in this region too. And therefore, that's the same as a box, but it's just in a regular shape. That's in addition to the boxes being essentially having the digits 1 through 9. Renban. Digits on a magenta line do not repeat and are consecutive in any order. So for example, if this were a 1, you would know there would have to be a 2, 3, 4, 5 on that line also, because the only set that contains 1 that's consecutive, that has 5 digits, is 1, 2, 3, 4, 5. Thermometer. Digits on a gray line increase from bulb to tip. So basically, that means this is constantly increasing from here to here and from here to here. So a potential valid example would be like 1, 3, 4, 6, 7, and this is 9, right? Because it has to be increasing from bulb to tip, but you don't have any interaction with this tip and that tip, right? It's just from the bulb to the tip. And that's an example of thermometer. And congrats, you now know 50% of the most popular variant Sudoku rules. And if you get stuck, look at column 1. It's always column 1. Okay, I'm not sure I get it. It does look interesting that this does look kind of like a panda, so that's pretty cool. I'm not sure why it's a trash one, but it is. Anyways, if you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so one thing we know. So here you have the digits. You have 2 digits in a 1 to 2 ratio. Now, the possibility for 3 digits adding up to 9 is either 1, 2, 6, 1, 3, 5, or 2, 3, 4. But the only ones in a 2 to 1 ratio are 2 and 1 and 2 and 4. So this always has to have a 2, and it's either with 1 or it's with 4. And so this is 2 with 1 or 4. If it's 2 and 1, this has to be 6. If it's 2 and 4, it has to be 3. Let's see. This therefore can, oh, that's interesting. This is 2, So this can't be 1 and 2 and cannot be 2 and 4. If it were 3 and 6, that would eliminate both possibilities here. So it can't be 3 and 6. Therefore, the only pair left that acts a 1 to 2 ratio that's possible here is 4 and 8. So this is 4 and 8. This adds up to 12, which means this has to be a 7. This can no longer be a 4. Therefore, this has to be 1, 2, and 6, which leaves here having to be 3, 5, and 9. And actually, we should have probably gone from here because this actually has 3 digits adding up to 7. And the only ones possible there is 1, 2, and 4. Now, because of this extra region, we know 1 and 2 cannot be in the rest of that extra region because we have a 1, 2, 1, 2 pair. Therefore, this can't be 1 or 2. Therefore, it cannot be 1. This could only be 1, 2, or 4. So therefore, this must be a 4, which makes these 1 and 2. So since these are 1 and 2, at least one of these must be 1 or 2. So therefore, this must be at least 1 or 2. One of them is at least 2. So this is at most. So this could be 1, 2, 3, 4, 5, 6, obviously. Or 2, 3, 4, 5, 6, 7. And those are the only possibilities. If it's a 7, it's here, right? Because it cannot be here, cannot be these 4, cannot be this one. Otherwise, it's, again, this can't be, this is 3, 5, or 6. And these can be 3, 5, 6, or 9. This can only be 3, 5, or 6 because, again, you can't have 7, and it's either 1 through 6, or it's 2, 3, 4, 5, 6, 7, and the 7 can't be there, right? So these can also be 3, 4, 5, and 6. And these could be 1 or 2, potentially. All right? This can't be 5 because 5 can never be on a German whisper line. In addition, actually, we have 1, 2, 4, 3, 5, 9 already accounted for in these 6 cells in box 5. So what are the rest of the cells? They must be 6, 7, or 8. So all of these are 6, 7, or 8, and therefore they're all high. Now, this has to be essentially 5 away from 6, 7, or 8. So it cannot be, it has to be from 2 of 6, 7, or 8 that it cannot be. So this can't be 6 because we have a 6, 7, 8 triplet in row 4. And this can't be 6 because of the same triplet. This has to be 5 away from 6, 7, or 8, so it cannot be 4. This must be 6. This must be 5 away from either 6 and 7, 6 and 8, or 7 and 8. So at least it must be at least 5 away from 7. So this is 1 or 2. In addition, we know one of these is 6, so therefore one of these two must be 1 to be next to a 6, right? Because 6 can only be next to a 1 on a German whisper line. Therefore, we know the 1 has to be one of these two. This is also 1, 2, or 3, and this is 1, 2, or 3, possibly because we know if it's 8, it could be 3 and 3 at most. So this can never be 1. We have a 1, 2, 3, 1, 2, 3 triplet also in row 4. Actually, no, this could be many things, actually. This could be 1, 2, this could be 9. It cannot be 6, but it could be 3, 4, and 5. Okay, so no, we don't have a 1, 2, 3 triplet there. This is also 1, 2, or 3. And it cannot be 1 or 2 because we have a 1, 2, 1, 2 pair in box 6. And again, we count from boxes. We say this is 1, this is 2, this is 3, this is 4, 5, 6, like how most Westerners read. This is 7, 8, 9. So for box 6, we have a 1, 2, 1, 2 pair, which eliminates a 1 or 2 in the rest of the box. So therefore, this must be 3, which forces this to be 8 because 3 can only be next to 8 of the digits that are left over. Therefore, this can't be 8. So this is 6 and 7. And 6 and 7 must be next to a 1. Because one of them has to be next to a 6, and 2 cannot be next to a 6 on a German whisper line. So this is 1. This can't be 3. These can't be 3. This has 6 digits. So therefore, it always has a 6, right? Because it's either 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, and this can't be 1. Because of this one. This could be 2, 3, 4, 5, 6, 7, or 3, 4, 5, 6, 7, 8. So it always contains a 6. It cannot be 6 on any of these cells. It can't be here, so it must be here. So this is a 6, which means neither of these are 6s. So that means one of these two is a 6. Because we know one of them has to be 6 on this line. And therefore, it cannot be any of these, can't be any of these. It must be one of these two then. Okay, let's see. This must contain a 2 or a 3. So this also contains a 6, right? Because it could be 2, 3, 4, 5, 6. Actually, it doesn't have to. It could be 1, 2, 3, 4, 5. It could be 2, 3, 4, 5, 6. It could be 3, 4, 5, 6, 7. And those are the possibilities. But 1 through 5 doesn't have to actually have a 6 on this. But we know there's a 3, a 4, and a 5. And the 4 could only be in one of these cells. Because it can't be here, it can't be here. This because of the German whisper line, and this because of normal Sudoku. We also know there's a 5 somewhere on this line. And there's a 3, but it could be any of these 5 digits. So 5 cannot be, 5 is one of these 4 also. And 4 is one of these 3, which means you cannot have a 4 or a 5 in the rest of the row. So this can't be 4 or 5. Let's see, what else do we have? This also must contain a 4 or 5. Because it has to be 3, it's either 1 through 6, or 2 through 7, or 3 through 8, which contains 4 or 5 either way. And again, this can't be 4 or 5, so we know the 4 or 5 has to be one of these 3. You can also be with 1 or 2, but if it's 1 or 2, it has to be 1 here and 2 here. It could be 2 and 7, though, so the 7 could be here, and the 2 could be here. Or it could be 3 through 8. So this can't be 8, but any of these could be 8, and this one could be 8. Again, this can't be 4 because of this 4. We know this is 4, 1, 2, and 6. This cannot be 9, right? Because it's the lowest point of a thermometer. It can't be 5 because there are 1, 2, well actually, there's one digit higher than it. So if this were 5, this would have to be at least 6. And this 6 then would have to have 4 digits that are greater than it. But it only has 3, 7, 8, and 9. Therefore, this can't be 5 and it can't be 9, so it must be 3. This can't be 3. This can't be 3. Therefore, this cannot be 3. This must be a 2. So this has to be 4, 5, 6, 7, 3, 4, 5, 6, right? So you have 2, 3, 4, 5, 6 to make consecutive. Actually, it could be 1. It still could be 1, actually. I keep forgetting that. So this has to have 1, 3, 4, 5, or 6. This is 1, 3, 4, 5, or 6. This can't be 3. This can't be 4. This can't be 6. Neither of these can be a 1. This can't be 2 anymore, so this is a 1, which makes that a 2. This has to be at least 4, which makes these at least 5, and these at least 6. So this is 6, 7, 8, 9, but in 3 digits cages that add up to 11, you cannot have, it must be It can never be 9, because if you have 9, you have to have 1 and a 2 at minimum, and that adds up to 12 already. So that's not possible. So this has to be 6, 7, or 8, which makes this 5, 6, or 7. So this must contain a 6, 7, or 8 with 11. So if it's 8, it's 1 and 2. If it's 7, it has to be 1 and 3. If it's 6, it could be 1, 4, or it's 2, 3. We're not sure which. This has to be 4, 5, or 6, because it has to be less than this digit. And this can never be. So if this were 7, it would be greater than this digit. This also can only be 4, 5, 6, 7, 8, 9. So this could be 5, 6, 7, 8, and this could be 6, 7, 8, 9. And this is 4, 5, 6, 7, 8, 9. Now here, this cannot be 4, 5, or 6. So this is 1, 2, 3, 7, 8, 9. But if this is 7, 8, or 9, at minimum, this would have to be 6, 7, and 1, right? If this cell were 7, 8, and 9, this is at minimum 6, this is at minimum 1, and this is at minimum 7. So therefore, that would add up to 14 at least, and it only adds up to 13 here. Therefore, this cannot be 7, 8, or 9. It must have one of 1, 2, or 3. This must have 1 from 4, 5, 6, or 7. This cannot be 1 or 2. So this can't be 1, 2, 1, 2, 7, because can never be a 2. So this is at least a 3. So therefore this can't be 7. Can you have a 3-cell cage, which means 3 unique digits adding up to 10 without a 1 or a 2? You cannot. Actually, we even know. So actually, this can't be 8 because of this 8. But we know where's the 1 and 2 in box 8. Cannot be either of these. Cannot be either of these. Therefore, it must be either this one or this one. Now, this is 2, which means this. Where is the 1 in this region? It can't be here, can't be any of these, can't be any of these. It must be one of these two. So this is a 1, which means this can't be 1. This is 2, which makes this 1. So this is either 1, 3, 6 or 1, 4, 5. Let's see. This can't be 1, therefore it cannot be 1, 2, 8 or 1, 3, 7. So it must be 2, 3, and 6. So therefore this must be 2, 3, 6. Therefore this must be 5 because it's less than the 6. This must be 4 because it's less than the 5. So this cannot be 4 and 5. This must be 1, 3, and 6. So again, you can't have a 4 here. You can't have 5, 6 here. You can't have 5, 6 here. So this must be 7. And this is at least 8 or 9. And this is at least 8 or 9. What else is left in box 8? It must be an 8 or 9. And this cannot be 2 and 3, so this has to be 1, which means this cannot be 1. So now we know this has to be 2 through 7 or 3 through 8. So 7 has to be one of these two. So this has to be a 7. This has to be a 4. This must be then 1, 4, and 8 to add up to 13. So therefore this is 9, which makes that 8. This can no longer be 3 or 5. This can't be 6, so this must be 7, which forces this to be 6, which means this can't be 2, because you can't have a difference of less than 5 on a German whispered line. So this must be 1, which means this is 1 through 6 then. So this cannot be 7. This can't be 1, and this can't be 1. We have in column 1 now a 2, 3, 4, 5, 6 quintuplet. Therefore, so that's 5 cells which require 5 specific digits. Therefore, the other cells in the column cannot contain 2 through 6 either. So this is 1 or 9. This must be 1, 8 or 9, and this is 8 or 9. So we know this has to contain 4, 5, and 6 because those are the only places they can now be in column 1. Therefore, this cannot be 4 or 5. So we have a 2 or a 3 here. This can't be 2 because of this 2, so this must be a 3. Therefore, there cannot be a 3 in the rest of the Renban line. So none of these are 3. This can't be 3. Where is the 3 in this Renban line? It can only be here. So therefore, this is the 3. This is now 2. This can't be 3 now, so this is 2, which makes this a 3. This can't be 1 or 2, so this is 4, 5, or 9. But this can't be 4 because of this 4, 8 pair in box 4. So, and this can't be 4 because of the 4, 8 pair in box 4. Therefore, where's the 4 in column 1? It has to be here. So therefore, this is 4, which means this can't be 1 or 4. So this is 5 or 6. This can't be 6 anymore because of that 6, so this must be a 5, which means this can't be 5. Let's see. We know that can't be 5. So where is the 5 in column 1? It has to be one of these two cells, which means 5 cannot be in the rest of the box, because the 5 in box 4 has to be in one of those two cells also. Therefore, this can't be a 5, which makes this a 9. This can't be 5 or 9, so that makes this 3 and 6. This can't be 6 anymore, so this must be a 5, which makes that a 2, which makes this a 6. So this can't be 6 anymore, which forces this to be 4 and forces this to be 1. This can't be 2 or 4. This can't be 7. Therefore, where is a 7 in box? We know this has to have a 7 on this rim band. So where is a 7 on this rim band? It must be here. So therefore, this is a 7. Where's the 4 now on this Ren band? It has to be here. Where's the 5? It must be here. And this is either 2 or 8. So the rest of this box, this must be a 5. This 1 eliminates this from being a 1, so this is 2, which makes that a 1. This can't be 8, and the only two digits left in box 6 have to be 8 or 9, so therefore this is a 9, this is an 8. This can no longer be 9 because of the extra region rule set, right? Because it must have the digits 1 through 9 once each in this region. So this can no longer be 9, so this is a 5, which makes this a 9. This 9 means there cannot be a 9 in the rest of the extra region, so this must be a 1. Which means this can't be 1. This can't be 1 anymore. This can't be 3 because of this 3, so this must be a 6, which makes that a 3. What's the only digit that's not in this extra region? It's a 5, so therefore this must be 5. What about these two? What are the extra digits? What are the digits that are not yet in this extra region? It's 3 and 7. This can't be 7, so this is 3. That's a 7. In the rest of this row, we are missing 6 and 9, but this can't be 9, so this is 6, and this must be 9. Since this is 9, that eliminates that 9, so that must be an 8, which makes that a 9. And now we're just doing Sudoku. So this can be 2, 8, or 9. Cannot be 8, though, so this is 2 or 9. This can't be 9. So this must be 2 or 8. We have a 2, 8, 2, 8 pair in column 9, so this cannot be, the rest of the column cannot contain a 2 or an 8, so therefore this is 9. This is 2 and 5 left over. This can no longer be a 5, so this is 2, which makes that a 5. This is 3 or 9, and this can't be 9, so this is 3, which makes that a 9. This has to be 4 and 7. This can't be 4, so this is 7, which makes that a 4. We have 8 and 9 here. This can't be 8, so therefore this must be a 9, which makes that 8. What's left over here is a 6. Right? Yep, this is 6. What's left over here is a 7. And then from these two must be 5 and 8. But this can't be 5, therefore that's an 8, which makes that 5. This 8 makes that a 2, which makes that an 8. We have 1 and 2 left over. This can't be 1, so therefore it must be a 2, which makes that 1. This 8 makes this a 4, which makes that an 8. This has to be 7. We're missing a 4 here, and this is 7 then. And that's how you Sudoku. Fairly straightforward, obviously. This is a very easy puzzle. And it introduced the extra region, so I hope you enjoyed that. It's very, yeah, this is, extra region I would say is probably the one that is the least used out of these rule sets. Thermometers you see a lot. German whispers you see a lot. Kropke dots you see a lot. And Renbands you see quite a bit. In cages, killer cages, you see a lot. If you get stuck, look at column 1. It's always column 1. I still don't understand that reference. Anyways, I hope you enjoyed this learning how to Sudoku with Trash Panda, and I'll see you next time on Frank Puzzles. Take care.